It's about time to almost put our toys away and put our toys away and get ready for a serious build, or at least attempt. I've had 2 days of thunking. I did all sorts of things like, thinking, can I put something in like that? Blah, blah, blah. Can I, if I take these things, I think I'm going to have to put it on the tripod, fellas. I've only got 2 sets of hands. But, yeah, time to go in and, sort of putting things in at different angles, and that's not going to be steady, is it? Get the tripod steady, but move the camera, that's better. I was thinking of doing things, repulsively and putting them around, one like that, and then another, like that sort of thing. Probably need spot colour for this, do we? Probably. Putting him like that sort of thing. And then on the other side next to it putting another one like that sort of thing, so sort of and then in between them having ones up like that and so on and so forth. But I'm probably going to have to show you on the ring, and I thought, no, that's just getting too complicated. And of course then I went back to back to where we were before, thinking, well, come on, there's something a little bit odd going on there. We were getting such good success. And then I noticed something that was pretty amazing, and I still can't work out at the moment. And I think I'm going to have to get out the iron filings again, just to see if we can get a handle on it, because I just can't explain it. So I'll show you. Get this on here, like this. At the moment I have no idea, and I can't see why it should be that way. Blah blah blah. No. What I noticed, we take our thing like this and do this. We'd already got to stage 1, which was showing that basically if you first of all, stage 1 was showing that there's no gating on the faces. So if you go with the gating on, there's no gating on the faces, right? And if we did this by 1 by 1, y equals x basically, you could actually spread the face out this way and get gating along the lines. So that's your idea about linear motion and putting your 3 trains on top and your 3 monorails underneath, sort of thing. Okay, I get you. And we started putting it on there, and we started getting a little bit of success, thinking, oh, this is getting too easy, how come no one else has done this in the past? And then we suddenly it became very difficult, and we couldn't get anything to work. Then I noticed something with this, very strange. So this is a staircase, right? Now, is it going up or is it going down? You see, are we going down the staircase or are we going up the staircase? Now what I've noticed, and also the other thing I found is it's best to put the things on the side. And the other idea was the fact that the stronger the force, the stronger the gating. So if you have gating, so basically gating occurs off the sides of the face. Okay, so there's your gating. Now the stronger the force, the stronger the gating. That's a really important point. In other words, it's like having a handbrake on your car. You put your foot on the accelerator and the handbrake, it makes the handbrake work harder, sort of thing. Do you understand what I mean? It's like you're putting your handbrake right into the ground, sort of thing, and you're thumbing it into the ground, sort of thing, like that. So it makes it happen. So basically, you got your first rule of motion, the law of inertia. A body at rest will remain at rest. So in other words, what you're doing is you're actually putting more force in, getting more gating, and you're keeping the wheel at rest. Whereas if you put less force and the way you get less force but low or minimal gating, so your wheel's not going to go round as fast, but it's going to go round. Whereas you put more force in, you get more gating, and your wheel doesn't even get started. You get the law of inertia, a body at rest remains at rest. Do you understand? See, the first rule, the rule of inertia, only states two things. It talks about rest and it talks about motion. It doesn't talk about the intervening time of getting it from rest to motion. So once you get the wheel going, it will remain in motion unless acted upon by an external unbalanced force. But of course it's getting it going, you see. And that's the second law, which is the law of momentum. F equals ma, force equals mass times acceleration. Or alternatively, you can bring the mass over on the other side of the equation. You say F over m equals acceleration. So in other words, if you have a large force and a large mass, you'll get roughly a y equals x acceleration. Or you have a small force and a small mass, you get a y equals x acceleration. If you have a large force and a small mass, you'll get something greater than y equals x. And if you have a small force and a little mass, a small force and a giant mass, you'll get very little acceleration, if at all, if you can't overcome friction. But then also, it's the way you interact, like with the Newton's cradle. If you understand, it's a longitudinal weight on Newton's cradle, and you can't actually get a mass greater than the hitting mass to actually move off. That's an important point about the longitudinal wave interaction sort of thing. You can't actually get something large, a mass larger than the mass you're hitting, no matter how fast. And then of course that sort of goes into your idea about frequency and photons and things like that. That sort of similar idea. Anyway, the other thing I've noticed, which is this is the strange part, which I still can't understand, and I'm going to have to get out my iron filings. It's your direction on your staircase. See, we're going up the staircase here at an angle like there, and you get a nice strong force. But if you go down the staircase, you get and have it in repulsion, you get a much weaker one for some reason, and I can't understand why that is. I can't understand why you get a smaller force going down the staircase. So there's the other thing. If we were doing it in the wrong direction on a wheel, we weren't getting enough oomph. So the important thing, if you want to get the wheel going, you need the more oomph you get, the faster the wheel and it's going to go. If you can get rid of the gating, if you have some gating there, you want the force to be less, so the gating will be less. And do you see you sort of going like a calculus problem here? It's heading towards an equaling out point. Okay, so that's the first thing. Now if you break this down into, like, it gets even more dramatic. So you got your staircase now, we just broke it down, we made the gap wider. You can actually feel there's sort of like a zone there, like that. But you put it around here, like here, and you can still feel the same zone. So, and it just feels exactly the same, which is why I can't really understand why putting it one way you got like that, and putting it the other way around you get a different amount of force. You see, I can't work that out. I just have no explanation for why that is. See, there's a lesser force there, but if I do it here, I get a stronger force in there. Whether it's just because you're just pushing away from there, or in there you're actually pushing against the mass like that. Is that all it is? You know, I'm just sort of pushing against the surface there, but it's like teeth on a cog there. I'm actually pushing into the teeth. Sort of, is that the difference? I don't know. Anyway, it's a long explanation, but there is a difference between which way you do it round. Okay, and then the next stage, so once you put this thing on here, we'll take the tripoders down, I think, to actually have a look at this. We'll probably have to go to another video because this one's getting too long and too dramatic, I think. But if we go down and put this on here, I have, as I said, now we're too low. Bugger. It's always the way, isn't it? You know? Yeah. And there we go. Right, now where are we? In the screen down there. Okay, so in other words, if we put this on here like this, like that, and of course we've got the blue deck to stop these from shifting like that, we should have a greater force one way than the other. So if I go like this, trying to push it that way, if I push it this way, it's much easier to push around. See, much easier to push around than if I, is it this way or that way? Yeah, that's it. So I push it this way, you can see the speed it's going at, whereas I do it this way, get it around the right way, there we go, you can see it goes much easier to turn and go the other way. So that was one of the problems we were doing. The next stage is a three-way idea. You know, putting these things like this, and we've got, trying to find the report. And that's another thing I was losing, touching the wheel. I'm losing sort of force touching the wheel, things like that. Yeah. So we got a force like that. Now there, and you can actually, you have the temptation of putting your magnets like this to get more force in like that. And this is an error I've worked out, because if this is, when it goes on this side, of course, when you go over the face you get gating. So basically what you think, oh, I'm going to get more force in there like that, because as the wheel goes round you're going to get the other side, so you're going to get gating around this point. So you've got to throw that idea out there. So basically you only have two dimensions. There's this one, is that down? Yeah, and that one. So basically you've got these two dimensions of there and there. So you push in there like that. That's your two dimensions there. I can get the force in there, and like that. What I've discovered is if you put it down like this, that's the best way. Down there like that. So you got this full face here, plus you got that sort of notch in there, sort of thing. But then we want to add this into that. So basically we want to take this and put it down like something like that. So, or sorry, the other way round. Yeah, the other way round, what is what I'm saying. So basically it's got to be on this side, pushing in that way, and vice. And the other thing I discovered is it's best when you have these things on the side there, yeah, you'll get some bit of gating going across this face like this. So it's better to either space them out, or alternatively put them on either side as well. So that is even better than, do you see that's starting to look like a bit like a water wheel or a paddle wheel on a steamer? You know, the way this is sort of in and out sort of thing. But anyway, we're going to try and put all this information together into our first major build. But I think we've gone on it a little bit too long, and I probably need to take some close-up shots as well. So over and out for now. See ya.